Hello everyone, my name is Rajan Amichani. Today I'm going to discuss a little bit about some of the research designs used in medical research. Here is the overview of today's session. I'll give you a brief introduction of the biostatistics and how this can be used in medical research. Then we'll go over some of the research schemes that is very useful in performing any kind of research. And finally, I'll go over some research design based on the different types of studies, where descriptive or analytical studies. When you think about any kind of research, one thing always comes into your mind is, how do I analyze the data? Because nowadays all research, they are data driven research, and when you have a data, then to make the data in order to data to make sense, you need to do some kind of analysis, you need to perform some analysis, and in order to perform the data analysis, you need biostatistics. Biostatistics is just the application of statistics in biomedical field. And statistics, it has four major parts: data collection, presentation, analysis, and interpretation. And nowadays, as I said, all research works, they are data driven, and no matter what kind of research you do, you always need this statistical method to prove or disapprove your hypothesis. And without hypothesis, it's really hard to justify any claim. And in the past, the field of statistics was not very popular. It's because in order to analyze large volume of data, you need high computing power. And in the past, there was no computer, and even though the theories, they were already developed in early 1700s, but statistics was not very popular, and especially there was no biostatistics that time. But after the advent of the modern computer, and it made all digital data acquisition very easy, and then it revolutionized the medical research. Research works that involve large number of subjects and that analyze several outcomes simultaneously at the time, that were not possible in the past due to lack of advanced computers. So the concept of precision medicine, big data, gene expression, proteomics, or RNA sequencing, they were not possible to do in the past. So when I say the medical research, nowadays the medical research is composed of three major parts. First, you should have medical data. Nowadays we have very well managed data system. You can get the data from Allscript or Epic. There are huge data warehouse nowadays, and now you can use those log data, which is already collected data, and then use some statistical tools to perform the analysis. And to implement those statistical tools, you need to use some computation power. And once you have all these together, then you'll do a medical research. For any kind of research, there are three primary goals of any research. First goal is the estimation. So when any characteristics in the large population that is unknown, for example, if you want to see what is the average percentage of diabetic population in West Virginia, adult diabetic population in West Virginia at this point. So in order to estimate that value, you cannot go to all individuals in the population, but you can take a random sample and then use the value from that sample to make a best estimation of the unknown characteristics. That is called the estimation. So if there is something that is unknown in the population, then we can use the sample value to estimate that unknown population characteristics. And the second goal is about prediction and association. When you are trying to develop the association between two factors, think about lung cancer and smoking. If you want to establish an association between lung cancer and smoking, or if you want to predict the obesity status based on several demographic and other diet factors, then you need to find some way to establish those associations, and this can be possible by using statistics or biostatistics. And another goal of any medical research is to perform the comparison between either two or more groups. You have treatment or placebo group, and now you want to see which group is more effective, or if you want to compare multiple groups and which group has a higher prevalence, then you need to perform the comparison. So these are the three primary goals, no matter what kind of medical research you perform. And here is a general research scheme for any kind of research. First, you formulate your research goal, and you then identify what is your hypothesis based on the research goal. And once you identify your hypothesis, then you have some idea, okay, I'll to implement some kind of models. And then once you have these goals and hypothesis clearly stated, then you plan your study. And when you're planning the study, then that time you need to know what sample size you need, what kind of variables, what kind of study variables you want to collect, what are the experimental units, and what is the sampling mechanism, whether you are collecting the sample randomly, or you are just taking the data from the data warehouse, or you are just going to do the survey or do any convenience sampling such as interview and other things. So you need to plan the study very well, and once you plan the study, then you start collecting the data, and then you start cleaning the data, you perform the data management, and you store the data. And after the data collection and cleaning is done, then the next step is to analyze the data and draw the inferences. So you can present your data through the graphs or through the quantitative displays such as mean, median, or standard deviation. And then you also perform the hypothesis testing, and you see whether your model is good fit or not through the model assessment. And once you have all the inferences drawn, then you make a decision, you write the conclusion, or you present your results through different dissemination methods such as oral presentation or manuscript writing or grant writing, etc. And sometimes when after the first preliminary analysis, sometimes you may not see the expected outcome from the data. In that time, you formulate the new research goal, and then you go back and plan the study again and repeat the same process. So this is the general research scheme for any kind of research, and it is especially very important for the medical research. And these highlighted areas will be our main focus in this course. There are different types of research studies: descriptive and analytic. And in descriptive and analytic research studies also there are several other types, and in our session today we'll go over all of these various types of research designs used in medical research. We can divide research studies into two types: descriptive and analytical studies. Descriptive studies, they obtain the information concerning the current status of the phenomena, and it answers the questions who, where, and when. So you can think descriptive study about the person, place, or time. When I say the person could be of age, sex, occupation, or any other variables. And also the place means workplace or residence or any hospitals, or time means it's a reporting time, diagnosis time, or testing time. So descriptive study, they help to generate the hypothesis. And descriptive study, you cannot prove or disapprove based on the descriptive study. It only shows you the trend, how the data looks like, and it helps you to develop any kind of hypothesis, and it just describe a pattern, and you cannot draw any causal inferences based on the descriptive study. There are different types of descriptive studies: in aggregate level or individual level descriptive studies. In aggregate level descriptive studies, we take the risk associated with the entire group rather than just going through each individual. We just consider the entire group and then we study the risk. And for the individual level, there are different types of descriptive studies: As I said, descriptive study, it just shows you the pattern, who, where, and when. There are different types of individual level descriptive studies. The case report, it reports an individual case or unique case, usually for the rare disease, and it contains the demographic information and other disease outcome information. And since case report contains very small number of samples and it has lowest level of evidence, it is just the one individual level data. And when you have multiple case report for the several individuals, then it is called the case report. And similarly, when you have a data and you just want to see the data at one time point, that's called, let's say this is just a snapshot of data and which only shows you a certain percentage or average at that time point, that is called the cross-sectional study or prevalence study. In another individual level descriptive study is the incidence study, where we just see the newly registered cases, disease cases, compare over the time, place, or person. And in our later slides, we'll discuss about the cross-sectional and incidence study. Here are a few examples about the descriptive studies. According to National Diabetes Statistics Report 2014, 9.3% of the US population have diabetes. So this is a cross-sectional study because it just shows you a snapshot of a data at one time point. Another example, in 1971, two physicians reported a case series of young women with clear cell adenocarcinoma of vagina. So this is a case series, means it has taken several women and then it studies the case report of those women. And another study, which is the incidence study, it is study of incidence and prevalence of diabetes death in young persons in the US. So this example here, it has the diabetes death of the young persons from 1968 to 2009. So it has both new cases and old cases. So it studies the incidence as well as the prevalence. And as I already mentioned, we'll discuss about incidence and prevalence in our later slides. Outcomes from the descriptive study, they are the foundation of any research analysis, and the primary statistical tool we use for these outcomes are either mean, median, or total, or percentage, or standard deviation. When you are dealing with the quantitative outcomes, the value that can be quantified, then we use mean, median, or total. And when the outcomes are categorical, means it has different levels like male, female, or ethnicity. If you have those kind of categorical outcomes, then we use a percentage or frequency to define the data. Now let me show another interesting example how descriptive study can be used to develop the hypothesis for the analytical studies. In this example, an epidemiologist from Georgia Department of Public Health, he wanted to see any pattern in the farm tractor incidents. So he collected the death certificates between 1971 to 1981 that were associated with the farm tractor incidents. And after collecting the data, he used this information to describe the problem in terms of time, place, and person, and then generated a hypothesis for further study. So we'll talk about this hypothesis in a moment, but first let's look at the descriptive epidemiology here. This bar diagram, it shows the number of deaths and the hour incident occurred. Now just looking at this bar diagram, what can you infer? You can see that the number of deaths are very low during this launch hour, and even in the night time it's very low. So the most of the accidents, they occur right before the lunch time or around 4 to 5 where the traffic is busy. So you can define a hypothesis that at this time, right before the lunch or during this office hours, there is high incidence of tractor accidents. So this data is useful in developing that hypothesis about the time. Similarly, you can also see the age groups, means the person. So just looking at this one, you can develop the hypothesis that the older individuals, they are more likely to involve in tractor incident dates compared to the younger individuals. Now this is about the person, and now let's see the location or where. So if you see this diagram, these numbers indicates the number of tractor incident dates in different counties in Georgia. And just looking at this one, you can see that most of the incidents, they occur on this area. So northern part of Georgia, most of the incidents occur. So you can develop the hypothesis that most of the incidents will occur in the northern part of the Georgia, and it may be due to the geological structure of this state, because these are the plain areas and a little bit mountainous area here. So this example, it shows you how you can use this descriptive summary or descriptive studies to develop the hypothesis. Now let's move on to the analytical study. And analytic studies are the main focus of all medical research, and we usually do the analytic study than the descriptive studies. It measures the association between exposure and outcome, and it also performs the comparison and also derive the hypothesis, and then we justify the hypothesis to derive some causal association. Analytical studies are carried out in order to test the hypothesis about exposure and outcome relationship. Descriptive studies, they answer the questions about who, where, and when, but the analytical studies, they answer how and why. So the results from analytical studies, they could be implemented to prove the significance of the outcome or the result. There are four major purposes of the analytical studies. First purpose is to test the hypothesis in order to justify the claim or prove or disapprove any kind of claim. Then we perform the hypothesis testing, and nowadays most of the research, they need a testable hypothesis. And by using hypothesis testing, we identify the significance of any hypothesis, and another goal is to establish the association. So how do you establish the association between two factors or more than two factors? There are several statistical tools we use to identify that association. Correlation, regression, independence, association. Analytical studies, they justify why and how, and if there is a well-designed research and unbiased research, then you can even draw the causal association, causal relationship. And you can also compare difference between outcomes. You can compare two groups or more than two groups by using the analytical studies. Now let me go back to the previous slide and show you. There are two types of analytical studies, the experimental and observational studies. Now let's focus on experimental study first. In experimental studies, investigators, they assign the treatment to the study participants either blindly or knowingly. So the investigator has some control over assigning the treatment. And one of the famous experimental study is the randomized controlled trials or randomized controlled designs, because it is less biased and it minimizes most of the confounding effects. And we consider randomized clinical trials are the gold standard. And experimental studies, they can be clinical trials or the community trials. And when I say the clinical trials, they could be uncontrolled clinical trials or controlled clinical trials. There are different types of controlled randomized clinical trials: parallel trials, crossover, factorial randomized withdrawal trial, and many others. Now let's discuss all of these in the next few slides. Community level randomized clinical trial is not very recommended nowadays due to the several ethical issues, and it is also hard to conduct the community level trial for a long time. In community level clinical trial, entire community is randomly selected, and then very similar communities. They are randomly selected, and then the treatment is applied. And this is here is one of the famous example of a community trial, and this study paved a way to use sodium fluoride for the dental hygiene. Two cities, Kingston and Newburgh in New York, they were selected for this trial, and both of these cities were very similar because they were just 35 miles apart, and they were both in the Hudson River, and they were getting water source. Their water source is from the Hudson River, the same river, and then the population was also very similar. Kingston, that time, it had population around 32,000, and Newburgh had around 29,000 population. And this time Kingston, it was considered as a controlled city, and its water source was left fluoride free, while for the Newburgh water source, sodium fluoride was added at 1 milligram fluoride per liter of water. And as I said, there are several ethical issues in this study, and there was a huge political pressure to stop the study early. That's why even though it was planned for 10 years, it was stopped after 5 years. 500 children from Newburgh and 405 children from the Kingston, their teeth were examined, and it is found that the sodium fluoride was good for the dental hygiene. Another clinical trial is uncontrolled clinical trial. In an uncontrolled clinical trial, there is no control group or placebo group in the design. It is just a single treatment design, means we just want to see how there is a difference from baseline to the endpoint. And this design is usually utilized to determine the pharmacokinetic properties of the new drug, how this drug works in your body. It wants to see how the value from baseline differs to the endpoint values. And usually it is used to see the half-life of the drug. And usually they are used in the preclinical or phase 0 or phase 1 trial. So just the take-home point for this one is that in uncontrolled clinical trials, there is no control or placebo group. We just want to see the difference between endpoint and baseline. Another very popular design is the randomized control trial, and randomized control trial is the most preferred, and it is considered the gold standard for all clinical trials, because since we randomly allocate the treatment to the different individuals, this randomization could be single blind or double blind, or sometimes it could be triple blind randomization. And because of this randomization, it is less biased, and it minimizes the confounding effect. It minimizes the subject effect. In randomized controlled trials, study is designed to remove as many sources of bias as possible, and results can be analyzed using standard statistical tools with high power, because since there is no confounding or minimum source of bias, then it gives high power even for the small sample size. And if the study is well designed, this randomization, it could lead to causal inference, one cause other, and then you can also generalize the result. If possible, the sample is also random. Even though causality is still a debatable topic, but well designed research where sample is randomly selected could give you the causal inference and could generalize the result for the entire population. Here is first randomized clinical trial, randomized control trial. The first randomized control trial was carried out by the physician James Lind in 1747, and that time scurvy was a significant disease among the sailors. And in the scurvy disease, several parts of the body, especially the gums, they get swollen and then even bleed, and people can die. James Lind, he was the first to carry out the clinical experiment in the history of medicine, and in his experiment for this scurvy disease, what he did is he selected 12 scorbutic sailors and he divided them into the 6 different groups, and then for each group he gave the diet. Community level randomized clinical trial is not very recommended nowadays due to the several ethical issues, and it is also hard to conduct the community level trial for a long time. In community level clinical trial, entire community is randomly selected, and then very similar communities, they are randomly selected, and then the treatment is applied. And this is here is one of the famous example of a community trial, and this study paved a way to use sodium fluoride for the dental hygiene. Two cities, Kingston and Newburgh in New York, they were selected for this trial, and both of these cities were very similar because they were just 35 miles apart, and they were both in the Hudson River, and they were getting water source. Their water source is from the Hudson River, the same river, and then the population was also very similar. Kingston, that time, it had population around 32,000, and Newburgh had around 29,000 population. And this time Kingston, it was considered as a control city, and its water source was left fluoride free, while for the Newburgh water source, sodium fluoride was added at 1 milligram fluoride per liter of water. And as I said, there are several ethical issues in this study, and there was a huge political pressure to stop the study early. That's why, even though it was planned for 10 years, it was stopped after 5 years, and then 500 children from Newburgh and 405 children from the Kingston, their teeth were examined, and then it is found that this sodium fluoride was very healthy or good for the dental hygiene. Another clinical trial is uncontrolled clinical trial. In an uncontrolled clinical trial, there is no control group or placebo group in the design. It is just a single treatment design, means we just want to see how there is a difference from baseline to the endpoint. And this design is usually utilized to determine the pharmacokinetic properties of the new drug, how this drug works in your body. It wants to see how the value from baseline differs to the endpoint values. And usually it is used to see the half-life of the drug, and usually they are used in the preclinical or phase 0 or phase 1 trial. So just the take-home point for this one is that in uncontrolled clinical trials, there is no control or placebo group. We just want to see the difference between endpoint and baseline. Another very popular design is the randomized control trial, and randomized control trial is the most preferred, and it is considered the gold standard for all clinical trials, because since we randomly allocate the treatment to the different individuals, this randomization could be single blind or double blind, or sometimes it could be triple blind randomization. And because of this randomization, it is less biased, and it minimizes the confounding effect, it minimizes the subject effect. And this is in randomized controlled trials, study is designed to remove as many sources of bias as possible, and results can be analyzed using standard statistical tools with high power, because since there is no confounding or minimum source of bias, then it gives high power even for the small sample size. And if the study is well designed, and this randomization, it could lead to causal inference, one cause other, and then you can also generalize the result. If possible, the sample is also random. Even though causality is still a debatable topic, but well-designed research where sample is very well and randomly selected could give you the causal inference and could generalize the result for the entire population. Here is the first randomized clinical trial. randomized control trial. It was the first randomized control trial was carried out by physician James. The first randomized control trial was carried out by the physician James Lind in 1747, and that time scurvy was a significant disease among the sailors, and in the scurvy then gums get red. Several parts of the body in the scurvy disease, several parts of the body, especially the gums, they get swollen and then even bleed, and people can die, and usually it's very common on the sailors. In James Lind, he was the first to carry out the clinical experiment in the history of medicine, and in his experiment for this scurvy disease, what he did is he selected 12 scorbutic sailors and he divided them into the 6 different groups, and then for each group he gave the diet. One group was given a quart of cider, another group was given the 25 drops of elixir of vitriol or the sulfuric acid, and the third group given 3/6 spoonful of vinegar. The fourth group were given pour half a pint of seawater. The fifth group received 2 oranges and 1 lemon, and the last group was given a spicy paste plus a drink of barley water. I'm not sure how he selected all these different type of treatment modalities, but maybe it's based on the practice existed that time. And here the interesting thing is that after 5 days, the fifth group, who received 2 oranges and 1 lemon, their supply ran out. Even their supply was ran out, they were the first group to recover from the scurvy. So this experiment showed that scurvy is a vitamin C deficiency disease, and then they started treating the individuals with the vitamin C, and that's how the scurvy was treated. And it is identified that scurvy can be treated by using vitamin C. One group was given a quart of cider, another group was given the 25 drops of elixir of vitriol or the sulfuric acid, and the third group given 3/6 spoonful of vinegar. The fourth group were given pour half a pint of seawater. The fifth group received 2 oranges and 1 lemon, and the last group was given a spicy paste plus a drink of barley water. I'm not sure how he selected all these different type of treatment modalities, but maybe it's based on the practice existed that time. And here the interesting thing is that after 5 days, the fifth group, who received 2 oranges and 1 lemon, their supply ran out. Even their supply was ran out, they were the first group to recover from the scurvy. So this experiment showed that scurvy is a vitamin C deficiency disease, and then they started treating the individuals with the vitamin C. There are different types of randomized control trials. First and very common randomized control trial is parallel design. In parallel design, the individuals, they are randomly allocated into different arms or different treatment groups. Here you can see in this picture here, these individuals are randomly assigned into 3 treatment groups A, B, and C. And after randomization, each individual, he or she will stay in their assigned treatment arm for the rest of the study. And here there is no carryover effect. We'll discuss that later in next slide. And here this parallel design, these are the gold standard for the all phase 3 trials. You have control group or treatment group or several treatment groups, and there is also the concept of the matched pair parallel design. Sometimes we think that some treatments, they have different effect on different group. Some treatments are more effective to the younger compared to the older, or some treatments are more effective to the males compared to the females. Means if there is a question about the effectiveness for different groups, then we can run the matched pair parallel design. In matched pair parallel design, first we identify the groups where we assume that the treatment will have different effects. Then from each group, now we randomly divide them into the different treatment groups. So in this example, you can see that let's assume this is female and male, and then first we screen these individuals and select the males and females separately, and each males are randomly assigned to the two treatments A and B, and similarly each females they are randomly assigned to another two treatments A and B. This is called the matched pair parallel design, and the benefit of the matched pair parallel design is that we reduce the risk of group effect. In both parallel and matched pair parallel design, we still have some individual level effect. Each individual has different response to the drug, and their genetic as well as environmental factors, they are also different for each individual. So we still have some individual level effect. And in order to reduce the individual level effect, we can use crossover design. In crossover design, each patient receives both interventions but in different order. First, individuals are screened, then they are assigned to the different treatments, and then after some time we stop those treatment and we wait for the effect of those previously assigned treatment to be washed out, and after that wash out period then we alter the treatment. So if the person is receiving treatment A in the first period, then after some washout period, the same individual will get another treatment B. So it means the treatments are altered after some washout period, and there is no control in this design because each person get all the possible treatments. So each person saw himself as a control, and it requires, since the same individual is acting on both treatments or more than one treatments, it means we need less sample size. But there is a huge risk of carryover effect. Even though there is a washout period, we still assume that after certain, because the effect of the previous drug may not be completely washed out. Okay, we still have some carryover effect when it moves to the second phase. Another design is a factorial design, and it is suited for the study of two or more interventions in various combination in one study setting, and it helps in the study of interactive effects resulting from the combination of intervention. So if you have more than two interventions, and if you want to find, and there is also the combination of different doses of those interventions, then the factorial design is very suitable for those kind of studies. And factorial design, it requires a small sample to identify the better combinations of drugs or doses. Usually, factorial designs are used to identify which dose of the drug is more effective, and we compare those doses of different drugs. In general, 2 by 2 is a very common design. 2 by 2 means there are two treatments. We are comparing two treatments or two interventions and two different doses of each intervention. And here is a pictogram of a factorial design. And another design is called the randomized withdrawal design. In randomized withdrawal design, we always consider only the responders. And here you can see in this picture here, after the screening of the eligible patient, first the drug is given to all individuals who are screened. After some time, not every individual respond to the drug. So all the non-responders, they are dropped out from the study, and then these responders are divided into different groups, placebo and treatment, and then we measure the efficacy at the end point. And this kind of studies, this kind of designs, they are aimed to evaluate the optimal duration of the treatment in patients who respond to the treatment, because we already removed the non-responders, means it is useful to understand the mechanism on the responders only, and it is appropriate to design the study to extract the most amount of knowledge from the limited number of patients, because these responders are the limited number, and in those limited numbers we want to extract the most amount of knowledge. And there are many other designs, matched pair designs, where you match each cases with the controls. And another design is called the delayed start design, where you keep the drug, then wait for some time for the next group, and then you start the drug for the next group after certain time. Means you start your starting time will be delayed. And there are also other designs like a three. These are the design and so on. Experimental research designs. Now let's move on to the observational study, which is another type of study where investigator he doesn't have any control over assigning the treatment, and subjects are observed and for some time, and then the results will be collected. So here is one example. We want to see the effect of smoking in lung cancer. So the group of smokers and non-smokers are selected, and they are followed over a certain period of time, and then the disease status will be recorded after some time. So this is one of the observational studies, because we are not assigning any treatment. You are not assigning any smoking to the individuals, but we are just observing them. Observational studies, there are three types of observational studies: cohort studies, case control studies, and crossover studies. The first type is called the cohort studies, which is sometimes also called the longitudinal or the follow-up study also. In cohort study, a group bearing the similar characteristics, they are followed for a period, or those groups are studied, and the participants they are classified according to the exposure status. Means one cohort is the cohort of exposure, another cohort is the cohort of non-exposure. So we always have the two cohorts there, and we want to compare those two cohorts. And cohort studies is also is a panel study. Means we study them over a period of time. Okay, but not all panel studies are cohort studies, because cohort studies contains the individual with the similar characteristics, but panel studies there could be other factors not common to all individuals. Here is one example of the cohort study: alcohol consumption and bladder cancer risk. And this was uh, a cohort of individuals from 55 to 69 years. They were studied for 6.3 years. If you want to see more details, then you can read this article. There are two types of cohort studies: prospective studies, which is also called the forward directional, and the retrospective studies, or the backward directional studies. So let me go over this prospective study. In prospective study, it's a temporal framework. It means we first have the exposure, then we follow those exposure status for a certain time, then we see the disease status. Means the cohort with the past or the current exposures are followed into the future and determine if the outcome occurs. Means we are looking forward in the future. So you have a study population, and here our study starts here. You have two groups, exposed groups and unexposed groups, where our study starts. Then we follow them for some time, and then for both groups then we identify the disease cases and no disease cases, and that's the end of the study. Means we are following these groups, these two cohorts, and find the outcomes, disease outcomes at the end phase. This is called the prospective study. Another study is called the retrospective study, or the backward directional study. In retrospective study, you know all the information at hand. It means most of the log data, means most of the data, medical data, what you already have, you can use this data, and you can see the cohorts and just find the cases in those cohorts. For example, if you want to see the effect of smoking in diabetes status, then you can see the Marshall data between 2010 to 2020. You already have the data, you already have the exposure status also. Then you can see the individuals who are smokers in that under already existing data. You can see the number of smokers and number of non-smokers. Okay, and then from those two cohorts, then in the same data set that you have, you can also see how many of the individuals they have diabetes after 10 years or 5 years, or how many of the individuals they didn't have diabetes. So this is retrospective study, because you are just looking at everything from the data, but you are just following the exposure cohort. That's what it is. So remember that your cohort is always exposed and unexposed, no matter whether it's retrospective or prospective. And in the retrospective study, you have everything in hand. So your study begins with all the data. Another study is called case control studies. Case control studies, they are always a retrospective study, because these studies are very useful when the disease is rare. And in such case, it is not possible to follow the cohort. Okay, we don't know how many in the cohort will develop the disease, because the disease is rare. In that case, what we do is you always we always identify the cases. Means the cases are the subjects, they have the outcome of interest or the disease, and then we find the similar matching controls. And then first we identify the case and control. Means first we have disease and non-disease case. Then we see among those disease and non-disease cases how many were exposed to the risk factors and how many were not exposed to the risk factor. So this is called the case control study, because participants are selected based on the disease status, not based on the exposure status. So what are the steps here for the case control studies? In case control studies, first of all, we start from the disease. How many individuals they have disease? Then once we identify the disease cases, then we identify the similar non-disease cases. And these are called the matching controls, because we need to have very similar controls. Is that the case? And then once you have case and control, then you see the data and identify the exposure history. How many were exposed to the risk factors, how many were not exposed to the risk factors, and so on. And one of the most important part in the case control study is to identify the controls. Cases are already there. You can only see the status of the disease, but for identifying the similar control is very important. And sometimes if you do not identify the appropriate control, then your result could be biased, or you may not get the outcome as you expected. So you have to choose the controls very carefully. And each controls, sometimes you can have one-on-one control, means one case one control case, or if you are trying to match with several factors, then you can have more than one controls for each case. You can match based on the age, you can match based on the gender, and so on. If the matching factors are more, then you always need more control for the one case. And remember that in case control study, we start with the case, means disease cases. Then we look for the exposure and non-exposure status. It means it is a retrospective study, because we already have everything. Okay, without having mm, without having all data, you cannot identify the disease. So case control studies are always retrospective, but cohort study could be retrospective or could be prospective. And there are different ways to identify the controls. Controls can be identified based on their status, matching status, what factors they match. Matching can be concordant or discordant. In concordant matching, both case and control will have the similar status of exposure or non-exposure. And in discordant matching, case and controls will be matched based on their opposite status. If the control is exposed, then case is not exposed. And as I already mentioned, the controls could be just one. Okay, one case versus one is to one, or one is to many, means one case with the many controls. It depends on how many factors you are trying to match. Here is one example of the case control study. So in this study, the participants who experience the acute myocardial infarction, they are the cases. Then we identify the similar controls who never experienced the AMI. And the exposure factors are the smoking. First, we identify the case and control, and then the smoking status is obtained from the data. Now, let me go over some of the differences between case control and cohort studies. Both of them look very similar, but there are some differences here. Cohort studies can be retrospective or prospective, but the case control study is always retrospective. And in cohort study, we always take two cohorts. No matter whether it's retrospective or prospective, you have an exposed group is one cohort, unexposed group is another cohort. Because you want to see how these exposures impact the outcomes. In case control study, you always start with cases and control, then you look for the exposure. So in case control study, the study group are the cases, while in the cohort study, the study group is the exposed population. And the comparison group in the cohort study is the unexposed population, while it is controls in the in the case control study. And cohort study is appropriate when you have rare exposure with this frequent outcomes. And cohort studies, it is easily accessible and less costly to collect the data, because you can just look at the exposure and then look at the outcome. And cohort study, since it is the temporal framework, means the exposure happens before the outcomes, then you can investigate multiple outcomes for the same risk factors. On the other hand, in case control studies, since we start with the cases, it is good for the rare disease. Also, when the study of the entire cohort is very hard, then we use case control study, and it is less costly, because you already start with the disease status. And case control study is useful to identify the several risk factors of the same outcome. And in cohort study, as I already mentioned, we start with the exposure uh, cohorts or non-exposure cohort and look for the disease outcome. While in the case control study, we start from the disease outcome and look at the exposure status. So it is called non-temporal framework. And for cohort study, you need more samples to achieve the good power. While in case control studies, since we already have disease cases, we need less samples to achieve the same power. It is important to know different types of research designs, as the analysis as well as the interpretation of results depends on what type of research design we are using. Another type of observational study is cross-sectional studies. Cross-sectional studies, these are kind of snapshot at a time point. So it examines the characteristics of a population at one time point. And in cross-sectional studies, both exposure and outcomes, they are measured at the same time. So we don't look at any other factors. It just gives you certain value at one time point. For example, percentage of the diabetic population in 2014 is 10%. Means it just give you the overview of that population at certain time point. That's all. And it is less time consuming and less expensive. And in cross sectional studies, you already have everything in hand. Okay, so you already have all the data, and you are not looking at any factors or anything here in the cross sectional study. You are just looking at the value, certain value at one time point. That's all. And in cross sectional study, there is no trend analysis, or there is no causality, okay, no hypothesis testing, because it is just good for the cohort discovery, how it looks like. It doesn't say anything about the trend or the relationship. There are some less common types of observational studies. One is twin concordance study. In twin concordance study, we compare the monozygotic and dizygotic or the fraternal twins to see the concordance rate. And monozygotic means they are the identical twins. And identical twins, it happens when the same egg is divided into two parts. And the dizygotic is there are two eggs, they are fertilized at the same time. In twin concordance study, we look the similarities between the identical twins themselves as well as the non-identical twin themselves. Also, we also check the difference in between these two pairs of twins within themselves and between themselves. So we compare between twin and identical as well as twin versus twin. And our main goal is to see how the genetic as well as the environmental factor they differ the traits of these twins. And adoption history, it is very similar to twin concurrence history, but it compares the siblings raised by biological versus adoptive parents. Means it's about more about the environment. In previous case, it's more about the genotype factors. Here, adoption study, we want to see how these siblings differ for both biological and adoptive parents. And it is used to estimate the degree of which variation in a trait is due to environmental and genetic influences. And it also compares the heritability or the genotype and effect of environmental factors, phenotype. Thank you very much. Now, next session, we'll discuss about the analysis of observational studies and how do we quantify the risk.